Hello, how are you all? I hope all of you are doing great in your life. So, today's lesson is so interesting because in today's lesson, I have brought to you a very important and interesting topic called regression. So, let's start the topic. First of all, we should know what is the meaning of the term regression. So, the meaning of the term regression is stepping back towards the average. This is the meaning of regression. Next, it was first discovered or used by a British mathematician called Sir Francis Galton. Okay, this is the picture of Sir Francis Galton. He is also known as father of regression. Okay, so what is regression basically? It is nothing but the mathematical measure of average relationship between two or more variables, where one variable is your dependent variable, another is independent variable. Okay, so in regression, basically the relationship between independent and dependent variables expressed is a function, and such functional relationship between two variables is termed as regression. So what is independent variable basically? So independent variable or predicted variable or explanatory variable, those are same, representing the cause. Okay, so the variable which representing the cause is known as independent variable, which is also denoted by x. Okay, so sometimes people may call regression as a cause effect relationship because of this reason only, where one variable is dependent and another is independent. So independent variable which representing the cause, which is also denoted by x, and dependent variable which is also known as predicted variable, explained variable or response variable, which showing or representing effect is known as dependent variable, which is denoted by y. Okay, this is an example, rainfall and yield. So here our rainfall is independent variable, yield is dependent variable, because yield is depend on rainfall, rainfall is not depend on yield. Okay, so this is basically showing a regression line. So the simplest type of such relationship is linear one. Okay, the prediction process would be more simpler if we can establish some kind of mathematical relationship between two variables. And the simplest type of such relationship is nothing but a relationship, linear relationship. So here in this lecture we will concentrate on linear regression. Okay, so what is a regression line basically, and what it describe basically? So a regression line is a straight line. Here you can see a regression line is a straight line which describe how a response variable, okay, response means your dependent variable changes as an independent variable changes. That's what a regression line describes. Okay, so this line describes the average relationship, or in other words we can say this line describes average relationship between two variables. Okay, sometimes people may also call it as line of regression or line of best fit. Okay, and this line will gives the best estimate to the value of one variable for any specific value of the other variable. Okay, this is the line. Here you can see x denoting independent variable x and y dependent variable. These are the points, actual points, and this line is the average, showing average relationship between independent and dependent variable. Okay, so here classification of regression analysis. There are different types of regressions available. First is your univariate regression, where only one quantitative response variable, if you have only one quantitative response variable, then that regression will be called as univariate. Only one quantitative response variable. Multivariate means two or more quantitative response or dependent variable. Next is our simple, means only one explanatory variable. Multiple means two or more explanatory variable or independent variable. When you have only one independent variable, then that regression will be called as simple regression. If you have two or more than two independent variable, then you will have a multiple regression. And when we will call it as linear, when all parameters enters the equation linearly, then we'll be call it as simple linear regression, otherwise non-linear regression. Okay, now we'll be discussing about simple linear regression. So before that, we should know the uses of regression. Why should we know about regression? There's the basic uses of regression. The first is it helpful in predicting the value of one variable from the given value of the other variable. Okay, such predictions are very useful when it is very difficult or expensive to measure the dependent variable, that is your y. In that case, regression analysis will give you the best result. Okay, otherwise other uses of regression is like to find the causal relationship between variables. Okay, in that case also we are using regression. Okay, suppose we manipulate the variable x and obtain a significant regression of variable y on the variable x. Okay, thus we can say that there is a causal relationship between variable x and y. Okay, such examples of causal relationship is your relationship between nitrogen content of soil and growth rate in a plant, or else doses of insecticide and mortality of insect population. These are showing causal relationship, means one variable causing the other variable. One is your causing variable, another is your effect variable. For example, in the first case, our nitrogen content of soil, it is your independent variable because growth rate is dependent upon nitrogen content. If you are putting more, if your soil is having more nitrogen content within it, then the growth rate of the plant will be more in that case. That means here your nitrogen content is independent, which is causing the growth rate of a plant. Okay, that's why it is a causal relationship. Okay, using regression you'll be able to find out such causal relationship between variables. These are two very important use of regression. So now what are the basic assumptions? So if your data is not supporting these four assumptions, then we cannot go for regression at all. So what are those assumptions that we need to know? First is your x, that is your independent variables and non-random or fixed constant. Okay, the x is not at all random, that is your independent variables are not random, they are fixed constant. Okay, next is at each fixed value of x, that is dependent variable, the corresponding value of independent variable have a normal distribution about a mean. That is, your independent variable have normal distribution. Third is, for any given x, the variance of y is same. Okay. Fourth is, the value of y observed at different level of x are completely independent. Okay, no matter at which level you are observing the value of y, your different levels of x are completely independent. That means the value of y's are completely independent of the level of x. Okay, now Now we know that what is regression and all, and what is the regression line. Now we should know that how to draw a line. That means drawing a line, that is also known as fitting a line. Okay, fitting a line is nothing but drawing a line that comes as close as possible to the real points. Okay, so we do have a very important method. There are so many methods are there, but here the most common method of fitting a line, that means drawing a line to a scatter diagram, is least square method. Okay, this is the most important method. So here we have our regression line, which is y equal to a plus bx. This is a line, regression line, where a is your intercept, b is your regression coefficient or slope. Okay, regression coefficient or slope, this is also known as slope. Okay, basically line gives the best estimate. Okay, it gives the best estimate, and line of regression is obtained using principle of least square or method of least square. So okay, in case of two variables, so here we are considering simple linear regression. So we have two variables, one is your dependent and another is your independent variables. Okay, in such situation we get two regression line, as regression line of y on x and regression line of x on y. The first one is your y on x and x on y. So in such case situation, when you have two variables, when you are considering simple linear regression, in that case we'll have two different regression line. One is for x on y, another is y on x. Okay, so this is the basically regression line of y on x. Okay, so where a is your intercept and b is the regression coefficient. Okay, here b is also known as slope, that gives the amount of change in dependent variable corresponding to a unit change in the independent variable. Okay, that means if your change is unit change is happening in independent variable, what's the situation of dependent variable, whether it is changing or not and how much is changing, that b will show you that value. Okay, so this is the regression equation of y on x. Okay, and now using this least square method, this is our regression coefficient formula. So if why we need this a and b, why do we need to calculate such values of a and b using such different methods? Because if you know the values of a and b, you'll be able to predict the value of y. So in this line is very clear, it is very clear that if you know the value of a and b using given value of x, you'll be able to predict the value of y. Okay, unless or until you don't know the value of a and b, it is not at all possible to calculate the value of dependent variable. So this is the basic formula of regression coefficient y on x, that is covariance of xy divided by variance of x. Okay, and this is the intercept, y bar minus b x bar. So here x bar and y bar is your mean of y, mean of x. Clear? So likewise here we have the second equation here, regression equation of x on y, which is x equal to a plus by. Remember, here x is our dependent variable, y is our independent variable. Clear? So this is the formula of regression coefficient of x on y. So here covariance of xy divided by variance of x. This is the intercept formula. Clear? So these two methods are same, just differences. Here our regression coefficient is covariance xy by variance of x, here covariance xy by variance of y. So basically regression line of y on x is used to estimate the value of dependent variable for a given value of independent variable, and this estimate of y obtained by this line will be the best because the line minimizes the error of estimates in y. If you consider x is a dependent variable, y is an independent variable, then the regression line of x on y is used to estimate or predict the value of variable x for given value of y, and it estimates x obtained by regression line of x on y will be the best because it will minimize same the error of estimates in x. So these two are different, so never get confused that these two variables are different, and most importantly for two different line we do have two different regression coefficients. These two regression coefficients are not same. Okay, next is property of regression coefficients. So property of regression coefficients are very important. People may, in some exams you may find that directly people are asking what are the properties of regression coefficients. So these are very important. First is your correlation coefficient is the geometric mean of two regression coefficients. So as we have discussed that we have two regression line, accordingly we have two different regression coefficient from each of those two regression line. So here the basic relationship correlation coefficient and regression coefficient is r is equal to plus minus root over beta b and b1. B stands for regression coefficient for x, y on x, beta 1 b1 is equal to regression coefficient of x on y. Okay, next is your if. Okay, this first property is also known as fundamental property of regression. Okay, this is also known as fundamental properties of regression. Next is your if one of the regression coefficient is greater than unity, then the other must be less than unity. Now this is very important again. This is also known as magnitude property of regression. Okay, that says that if one of your regression coefficient, that is either it might be either the regression coefficient of y on x, if your regression coefficient of y on x is greater than unity, that is 1, then the regression coefficient of x on y must be less than 1. Okay, that's the rule. If it's not coming so, then you have done mistakes. Okay, next is the arithmetic mean of regression coefficient is greater than the correlation coefficient. This is also known as mean property. Okay, next is regression coefficients are independent of change of origin but not of scale. Now I hope all of you have idea about change of origin and scale. Change of origin means if you are adding or subtracting from your data set, that is your change of origin. And if you are dividing or multiplying something, that is you are changing your scale. So in regression coefficient, if you are changing your origin, that regression coefficient will remain same, but if you are changing your scale, the regression coefficient will change accordingly. Okay, now next is if units of the regression coefficients are same as that of your dependent variable. Okay, next regression is a one-way relationship. Okay, regression is a one-way relationship, whereas correlation is two-way relationship. Now one-way relationship between dependent and independent variable. Next, the range of regression coefficient. What is the range? It's between minus infinity to plus infinity. Okay, now if your x and y are independent, if your x and y are independent, that is 0. What is 0? If two variables are independent, then correlation coefficient will be equal to 0. In that case, your regression correlation coefficient will also be equal to 0. Okay, now if theta, now what is the angle between two regression line? So this is the formula using which we'll be able to detect what is the angle between two regression line. So if your correlation coefficient is 0, then tan theta will be equal to infinity, or we can say the angle between two regression line will be equal to 90 degree, that is pi by 2. What I am saying is, if your two variables are independent, in that case r will be equal to 0. Then two regression line are perpendicular to each other. That means we will not be able to predict one variable given the other variable in that situation. That means if your variables are not independent, if your variables are independent, then two regression line are perpendicular to each other. In that situation, we are not able to predict one variable given other variable. Okay. Next is, if your r or correlation coefficient is plus minus 1, then the angle between two regression line is equal to 0 or pi. 0 or pi means what? Means two line will coincide. That means if your correlation coefficients are plus minus 1, that is perfectly positively correlated or perfectly negatively correlated. In that situation, two regression line will coincide, okay, or parallel to each other. Now next is your both regression line passes through the point x bar y bar. Okay, so this is basically the intersection point of two regression line, x bar y bar. X bar y bar means mean of x, mean of y, mean of dependent variable, mean of independent variable. So two regression line intersect at this point. Okay, here you can see two regression line intersect this point. This point is showing x bar and y bar. It is must. Next, if regression coefficients are positive, that means if your beta and beta 1, that is regression coefficient of y on x and regression coefficient of x and y are positive, then r must be positive. That means sign of regression coefficient and correlation coefficients are same. Now we know what is regression and all, how to fit a line. Now we should know how to test the significance of regression coefficient. So we have two important method here. First is t-test, second is analysis of variance test. So in this lecture we're not going to discuss about these two tests. Just for your information, I kept this slide here. So just remember that we have two important tests, T and ANOVA or F test, for testing the significance of regression coefficient. These are the basic test statistics or ANOVA table for conducting such test. Okay, so let's take an example saying that the following data give the yield per plant, that is your y, that means y, or and days of flower of 11 PGNP plants. Now what we have to do is we have to fit regression equation both of y on x and x on y, and also we have to estimate y when the flowering period is 149. So this is the data we have. So basically we have these two columns, rest I have calculated these three. So now we know what we have to do. For fitting a regression line of y on x or x on y, we should have beta with us, beta, b and a with us, that is slope and intercept. And how to calculate slope and intercept, that I already know. We have our formula here. This is the formula. This is the formula. This is the formula of b x on y on x and b x on y. Okay, let's calculate b and a. So for calculating b and a, we need to have x square value, y square value, and multiplication of x and y. Okay, now this is the value of b, that means your regression coefficient of y on x. This is the value of regression coefficient of y on x, and from that table have calculated mean of x and mean of y, and a, that is your intercept for the first model. This is for the model y on x, this is for the model x on y. Likewise, you have calculated for the model x on y. So this is the basically formula of x on y, that is x y equal to a plus bx. The y equal to, what is your a here? A is minus 118.75, minus 118.7574 plus, what is b here? 1.62 into x. So now if you know what is the value of x, easily you can get the value of y. So this is the equation of y on x. Now we need to find out what are the equation of x on y. It's very simple again. Again we have to calculate our regression coefficient and the intercept term. So this is the regression coefficient and this is the intercept term. So this is our regression equation of x on y. Okay, this is the formula. So now if you put the value of y, definitely you will get the value of x. It is as simple as that. Okay, so now you can cross check these values. You have this question with you, so once you calculate those things, definitely you will get the same result. Okay, I hope you have understood all those things. Thank you for listening, and if you like my effort, you can subscribe to my channel and press on the like button. Thank you all. See you in the next video. Thank you.